This is our third video on power electronics simulations. In the last two videos we have discussed two basic circuits. The first one was DC analysis and the second one was an AC circuit having simple resistive and inductive load. Now we are going to simulate a circuit in which we are given three voltages. We have AC voltages 80 volts, 100 volts and 120 volts, and also we have to change the resistance value from 1100 to 2200 and then 4400. The value of inductance is given as 2 millihenry for all the three cases. Now what we have to perform, we have to find the P1. P1 means that we have to find the source power, and P2 means we have to find the power across the resistor. Then V1 is the voltage across the resistor and V2 is the voltage across inductor, and then finally we have to find the I1. Now all the three components, source voltage, resistance and the inductance, all are connected in series. This is a simple series circuit. So let's start with the power electronic simulations. What you need at the first place, you need an AC voltage source. AC voltage. Now how to drag components directly, I have already discussed in the first two videos. So if you have not visited those videos before watching this video, I advise you to go and watch those two videos before performing this video, because I'm not going to repeat all those shortcuts or practices that I will be using in this video. Okay, I have to keep 80 volt RMS, so I have to give peak value here, so I am multiplying 1.41 into what is the voltage given. Given voltage is 80, frequency is 50 Hertz. Okay, now I need one ammeter. So ammeter is current measurement block. Okay, series RLC branch. Voltmeter, scope, RMS, power GUI, all these blocks have been discussed in the first two videos. Okay, let's copy it. This will be my resistance. What is the value of first resistance? 1100 ohm. So 1100 ohm. Inductance 2 millihenry. Okay, this is resistance and this is inductance. Now connect them together. It is always preferable to first create a series circuit, then after that add voltmeters. So I need V1, this voltage across the resistor, so I am connecting 1 voltmeter across the resistor and 1 voltmeter across the inductor. This will give me VR1 or VR, and I'm just copying it. This will give me voltage across the inductor, VL. Okay, now for source voltage, and then I want to get RMS values. Connect RMS block here. Also I need RMS current. Okay, now I need display. Okay, I don't need scope for instance, so let's delete it. Okay, this is 80 volt RMS, and I am giving this Simulink a peak value. Let's change RMS value, frequency of the RMS block, 50 Hertz. 50 Hertz. It's better to change at the first place and then copy its block, so that you do not have to replace all the frequencies. Okay, now let's run it for 1 second. Now you can see we are getting RMS values of 64, but the values I want to give in RMS is 80, so it means we are not giving a correct factor of multiplication here. So I think it's 1.41 instead of 1.14, so it is 1.415, 1.415, or you can simply write square root of 2. Because in order to find the RMS value, you have to divide peak value by under root 2, and similarly in order to find the peak value from RMS value, you have to multiply it with square root of 2. So square root of 2 is nothing but 1.415. So I hope this will give me 80 volts at the input. Yes, so this is giving me exactly 80 volts RMS as the input. And now what is the current? Current is 0.07. okay, and the RMS value, voltage across the resistor, yes, that is that is the case where all the voltages are being dropped. So 80 volts here and almost 0 volts at the inductor. So we will fill our first table. Okay, I need power also. So in order to find the power, I want to multiply the voltage and currents. So let's bring product block. Okay, so this will give me P1. P1 means source power. So first signal is VRMS, second signal is IRMS, then display. Also I need another power block. P2 is which one? P2 is power across the resistor. So this is P2. Okay. So voltage here, not here. I need RMS voltage. So voltage here and current here. Then display. Okay, now let's run it again. Now I'm getting P1 also and P2 also. Now you can fill this table with the help of this data. So what I am giving? I am giving 80 volts RMS. This is 80 volt RMS. I am using 1100 ohm resistance and 2 millihenry inductors. So what I am getting as P1 source power. Source power is this one, 5.81. So 5.815. Yeah, 5.8. So what is the source power? 5.8. This is in watts. What is the P2? P2 is same as 5.81 watts. 5.81 watts. What is voltage across the resistor? Voltage across the resistor is 80 volts. And what is the voltage across the inductor? Inductor voltage is almost 0. So it is 0. What is the value of current? Current is 0.07. 0.07. Okay, now we have to change the source power, source voltage. So I have to just replace it with 100 volts. 100 volts and then run it. Okay, so I need to change the value of resistance also. So go to the resistance and change it to 2200. Now let's run it again. Now what is the source power? Source power is 4.5 watts. 4.5. Also, what is the power across resistor? This is 4.5 watts. 4.5 watts. What is the voltage across resistor? It is 100 ohm. voltage across inductor is again 0, current is 0.04. Now let's change its voltage from 100 to 120. And value of resistance to 4400. Let's run it again. So source power is 3.27, 3.27. Power across the resistor is 3.27. What is the voltage across the resistor? It is 120. What is the voltage across inductor? Is again 0, and the current is 0.02. Now there is one question, why I am getting inductor voltage is equal to 0 in all the three cases. It is due to the fact that we are using a very small value of inductance. Now what we will do, we will increase the value of inductance so to check either voltages will be drop here or not. So we have 2 millihenry. I will increase it to 200 millihenry. Okay, so let's run it again. So you can see now voltage drop is increasing, 1.704. Let's increase its inductance value more. Let's increase this 2000, or 2000 milli means 2 Henry. So run it again. Now you can see a significant change in the voltage drop here. Now 16.9 or 17 volts are being dropped at this resistance inductance. Also, if you want to see the power absorbed by this inductor, you can bring one product block here, then multiply it with power of this inductor, voltage of this inductor, and then current of this inductor. So current is simply this one. Bring display. Run it again. So you can see before the, let's delete it first. When our value of inductance was very small, the power absorbed by this resistance was 3.4 watts. But now as we have increased the value of inductance, now power absorbed by the resistance is 3.208 and the power absorbed by inductance is 0.4665.